on to the next topic here, which is digital twins. And before I talk about what a digital twin is, because we'll go through that in a moment in higher resolution, I want to talk about a problem that we've probably all faced before. And that is that unscheduled maintenance is an $8 billion annual problem for passengers like us, but also the airline industry. And I'm sure we've been stuck somewhere waiting for a plane to have emergency repairs. This was actually a case study that was done by General Electric about 3 or 4 years ago. And when they ran their digital twins simulation, they found something remarkable. They found that a 10-minute conversation with this digital twin saved them $12 million in 10 minutes with just a simple adjustment on how that turbine operates. That's a really high ROI if you think about where a digital twin can take a company that is reliant on uptime and making sure that they have the right capacity at the right time at the right place. So maybe we should talk a little bit about what digital twins are and how your company can easily implement such concepts. First, a digital twin is nothing more than a virtual model of a process or a product or a service. So it could be anything, but it has a living component in the real three-dimensional world. And they can, but they don't have to, also integrate Internet of Things technologies, artificial intelligence, or software analytics that creates living digital simulation models that continually change and update as their physical counterpart changes. That's a bit of a more advanced concept. And we're going to talk through how someone can get started on a more nuanced scale, kind of moving in that baby step manner forward. So let's start simple. Like we said, a digital twin is literally something that just has to be something in real life that you're then moving into the digital world. So the first phase of a digital twin is to digitalize any information that you have. And it doesn't have to be sophisticated. It could be literally just two-dimensional blueprints that you're now putting into a digital format or has been created in something that's like even Adobe Photoshop or Illustrator. That's a version or a kind of first step for a digital twin architecture. From that point, we then can visualize the basic representation of a physical model. So this could then be taking something and having it in a three-dimensional environment, like this car you can see it in a CAD modeling software platform. And that would be kind of the next phase of how you move something from a two-dimensional space to a three-dimensional space within the virtual world. And then you start to simulate with that three-dimensional space. So then you can create simulation models of a physical environment around it. Wind, perhaps wind resistance, and computer simulation software like Simulink or others can help you kind of actually perform a lot of these tasks in a more routinized manner. Okay, and then what you can do is you can start to emulate the model of the physical systems with real software. So basically, this could be something like you see in that third example there, you have a car as like a macro unit, but perhaps you want to focus on the drivetrain or the steering assembly or the engine components and break down to kind of the nuanced details of how that actually would work and how they actually are operating within the physical space as a function of the emulated model. And of course, this takes a lot of time in development. So by the time you've gone from 1 to 4, you have mastery of kind of the concept that you're trying to digitalize. Everything I've just spoken about is just software. Now, if you talk about hardware, you can then, with real-time with sensors placed on your device, on a car, for example, you can start to pull IoT data right off of that machine and extract real-time data streams into your virtualized environment. From that point, you can start to create orchestration of the model within the virtual space as a function of the real space. So you're changing parameters in the virtual space and then updating the relevant systems in the physical space. So you tweak the engine components, or you tweak something in the like perhaps the steering assembly, and you're starting to see in the virtual realm, and then you can start to see how that translates out to how that would function in a real world environment. And then the last and probably the most interesting kind of area to kind of move within the digital twins space is then you take the prediction model or a predictive model of behavior that will happen based on the data you've collected historically using AI or machine learning to calculate everything from the asset lifetime to scheduled maintenance of those assets or those components, because now the model is saying after X amount of miles, you're going to need to replace this component or that component because of wear and tear that has been simulated first, validated in a real world environment, and now we have enough data to suggest that we can actually move forward in that space. Okay, so it's a long pathway, but it is something that you can do, and it can be done across a variety of different areas and focal points, and it does not have to necessarily just be cars. So let's talk a little bit now, if we were going back to those three companies of choice, what would healthcare potentially do with something of this nature? And healthcare would and is currently working to pull data from devices to then be able to simulate uh, biological functionalities. In this case, we're working on the immunological response model. So in this case, I would say, well, my company is going to digitalize, take the data from perhaps patients, and then simulate what immunological mechanisms are occurring based on this data pool that we have now that we previously never had. That's a version of a digital twins within the healthcare arena. If you're in the manufacturing space, this is actually one of the central areas where digital twins has been proven to be highly efficacious. There's many case studies out there that talk about integration of digital twins and IoT to decrease downtime and increase efficiency. And so we can talk a lot about that if we want to explore that regime. But manufacturing is actually one of the first places that digital twins took hold, and is a very stable product space in that area. Now, CPG and food, that people sometimes ask, what would CPG or food have to do with digital twins? And there's a lot actually that CPG and food are doing with digital twin technologies. Of course, everything from the manufacturing side or the process engineering side of the equation, which ties directly into manufacturing, but on the actual look and feel of the bottle, the strength of the bottle or the packaging, the handling of it. Maybe we find a way to remove all that runny stuff that comes out of the ketchup bottle in the beginning, who knows, right? There's many different ways you can simulate experiences using advanced simulation models now that would perhaps help even someone that may have not thought that that digital twins would be a viable technology. It absolutely is something that we are seeing continue to evolve in that particular domain. So that's just digital twins in a nutshell, and we are ready to move on.